Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I'm going to do is do a masterclass of array callback methods. So I'm going to assume that you may have seen my videos on callbacks, on functions, or are aware of these things before, and arrays before watching this video. So if you're not familiar with arrays, go watch the array masterclass video. If you're not familiar with callbacks, meaning functions being passed as arguments to other functions, go watch the callbacks video. And if you're not familiar with functions, go watch the functions video. I'm not going to necessarily retrace every little footstep there, but we're going to get these array methods and locked down. And these are not all array methods. I do have a separate video just on all array methods in general. This is specifically the callback methods, the ones that actually take a function as an argument. So we'll go through like each one. So I'm going to create a new file. Let me just open my terminal. I'm just going to touch callbacks.js. Okay, and in here, what we're going to do, okay, is create an array. So const my array, and it's going to equal, we're going to have 1, 2, 3, 4, 5, 6. That'll be our first one. And then we'll have const my array 2, which will be an array strings, just so you can kind of see like the difference between these two different data types if we use them in these functions. Me, you, I. Okay. So first let's talk about for each. For each is just really a loop. That's all it does. It loops over each item in the array. So the basic way it works is that you take the array, so my array dot for each, that's the function. And then you'll see from the vast majority of these callbacks, they take a function as an argument, and the function should always look the same. So we start off with like an empty arrow function. That's what you're passing in as an argument to each of these. So again, if you're new to this, always just start off with like sort of again that empty function. That's just going to give you sort of a formula or routine until you get really used to this. And then in here, the two things that this function will always receive, it's going to receive whatever item we're looping over. So we'll just call it item. And it's going to receive the index of that item. Okay, so if I were to just console.log item and then console.log index, let's see what happens. So node callback.js, and let's just open this up a little bit. So see, at first it logged, see the first item is the items because the first item is 1, then the index of that is 0. So you see in each loop, it has the item and the index of that item in the array. You have these two things available to you. You can do whatever you want with them. And that's really what for each does. It's just if you want to loop on it and you don't want to use a for loop or a for of loop, a for each loop can be a very nice way of looping over an array. Okay. Particularly useful when you're chaining like lots of functions together. So like a really good use, like if like let's say I generate an array from some other method. So when we do map, that'll be a good example. But then after I created that array from that method, I'm going to then loop over it. I can chain these methods together. So that's where like for each becomes super useful, so that we don't have to keep breaking everything down line by line by line by line. Okay, so that's for each. It's literally just a loop. But this signature, this function signature, is going to be consistent throughout all these methods. So it's like the item and then the index. Technically, there is a third argument we can define. So we can actually get back the array. So I can say r, and if I console log r with this third argument, it's actually going to pass the array itself in r. Okay, and you see there, each round I have access to the array as well. I rarely use that, but if you were planning to do some stuff with the array, that's one way to do it. Good question is it manipulating the original array, or is it a copy of the array? So let's actually test that, because I actually don't know the answer to that. So how would we test that? What I'm going to do is I'm going to manipulate r, not my array. I'm going to manipulate r. So I'm going to say r0 equals index. Okay, in that case, let's see here. And then what I want to do is after this is all said and done, I'll console.log my array to see if my array has changed. Okay. Oop. Node. There we go. So let's see here. So see, it does. Okay, so you are being passed the actual array. So if you modify that third argument, you are modifying the original array. Okay, so it's not passing a copy, it's passing the reference. I figured that was the case, but it's very possible that under the hood of the function they might have made a copy and passed that, so that way you would have a one to work with that wouldn't modify your original. That would have been nice, but that's not what they did. Okay, again, I never use that argument for the most part. It's there if you ever do have a situation where you need it, but for the most part the easiest thing to remember is just item index. Okay, just know you receive the item in index in each of these and make use of those. Okay, parentheses, there we go. So that's for each. Again, what does it do? It just loops over the array. It's just going to run this function one time for each item in the array. So again, ran it 1 for 1, then for 2, then for 3, and each time this function is receiving the item in the array itself and the index of that item in the array. It's going to be the same pattern for map. Map is arguably a much more important function. I use map like I drink water. What map does is that it creates a new array from the return values of the callback. So in this case, if I took my array dot map, I start out in the same place. I pass it in an arrow function. So I'll just pass it in, start off with an empty arrow function. Again, this function will still receive the item and the index on each loop. Okay, and we're gonna actually this method returns something. So we're gonna want to save that return value. So we're gonna say const result, and then we'll log that result so you can see what happens at the end. So the result of this is going to give me an array of whatever this function returns. So for example, if I just said return whatever the current item in the array is plus 1, that means on each loop I'm getting whatever that item is plus 1, so I should end up with an array of everything plus 1. So, and that's what we ended up with, okay? So generally this is a great tool when I need to change like everything in an array by this in the same way. So maybe I need to capitalize everyone's name in the array. Or, okay, so for example, let's do that. So in this case, see here, this is all lowercase, and I want to capitalize them all, make them all caps. Okay, so I can do like const result 2 equals my array 2 dot map. Okay, I pass in the arrow function, set up the item and index, so that way I'm receiving the item and the index. And then all I really want to do is just say return the item dot to uppercase. And again, it doesn't have to be one line. Like I can make this function as complicated as I want. Like I could go like, well, first we'll do it where we make it completely uppercase. Then I'll show you what would it look like if I just want to make the first letter uppercase. So I do this, and well, I should probably console log result to 2. So let's change that. And you see, like, what it did, it's not, the original array is still intact. So like if I console log the original array, my array 2, the original array still has the lowercase version. That's the great thing about map. It doesn't change the original. It gives you a new array with the changes. So that way you still have the original if you need it. Okay, it's a lot easier than looping over it and then modifying the original, and then if I need something from the original I have to go back and get it in some untransform it in some way. This way you just say, hey, here's the original, let me make the changes I want. Now I have both. Okay, which is, I don't know, it's more of a functional style programming. It's become more sort of the way I think about problems over time. I very rarely like manipulating the original like source set of data. Always like making a copy and then making my modifications to it and kind of moving forward in that fashion. Cool. So now let's see how to look like I could make it more complicated. Let's say I only wanted the uppercase the first letter. Okay, so first I want to split it. So we'll say const split equals item dot split. Okay, by that. Then what I would do is I would just take that, uppercase the first letter, dot to uppercase, and then I would, you know, const result equals, I will just say final, const final equals, we rejoin that array to a string, join back into a string, and then we return the result of that, final. Okay, so this uppercase is the first letter, and then I'm returning that uppercased version. So now if I look at this, oh, that didn't quite do what I wanted to do. Okay, let's think about that. I split it by letters, so then I would split this into like M and E. Then I'm saying take the first item in that array to uppercase. Oh, because it doesn't transform it, it just returns it. Okay, so what I should do is say split 0 equals splits to uppercase. So uppercase the uppercase version of itself. That way it's saved, and there we go. Me, you, and I are uppercased. So again, this can be very complicated. Like you can make some really complex transformations because you might be comparing it to some data you pull from another source, but whatever it is, it's going to create a new array of whatever that function returns. So it's just going to keep repeating that step over and over again. So the beauty of this is I don't have to think about the logic of looping. I just have to focus on what do I want to do per loop. Okay, it abstracts of having like to set up a for loop and then having to construct an array and push those items into that array. I'm just like, I got this item, what would I want to transform it? Like how do I want to change it? And then return that one item, and it takes that logic and applies it to all the items. And so that way I don't have to think, do that extra level of iterative thinking, and also just saves me a lot of time. So these methods are amazing. They're generally in every language, so not just JavaScript. But that's map. Map is great. Okay, and then there's filter. Okay, filter, that's going to return an array of items that the callback returns true. Okay, so let's say const result. So let's pretend I only want the even numbers in that numbered array. So const result equals my array, the first one, dot filter, and then again I pass it the function. The functions, this is always kind of like the same thing. So it's the item and the index. You don't have to say item and index. You can call them whatever you want, but again, if you're new to this, it's easier to kind of have a consistent way of doing things until you get comfortable with like when you like what you should name them. Like typically what I would say, like this array might be an array called nums, and then I would call item num because it represents one num of nums. But until you get comfortable with that, this is not a bad way of doing it. Item and index should pretty much always apply. They should always be semantic in pretty much any context. Okay, so my array.filter, what you want to do here is you want to return true or false. If the function returns true, that item stays in the array because it's going to give you a new copy of the array with only the items where the function returns true. So if I just wanted to return the even items, I could just say, hey, return, and then I'll just say item modulo 2, just the normal way we check if an item is even, equals 0. Okay, so there's a Boolean expression, and that will return either true or false, but it only returns true for the even items. So now if I console log this result, I should only have the even items. 2, 4, 6. Okay, 2, 4, 6. Okay, and then that's all fine and good. Okay, and then I can do it any way I want. I could do something like if I want to get the odd items, I can say okay, do that, and see it's only going to give me back the odd items. And I can do all sorts of really kind of complex checks. Though all that matters is that it returns true or false at the end of the function. How I end up to that, how I get to that true or false, doesn't matter. But that's how filter is going to work. So it allows me to create as complex a filter as I want on the array. So for like large sets of data where I need to ask a very specific question, filter can be a really kind of good way to kind of like narrow down that data set to just what I need. Because I can check multiple things and say, hey, are all these things true? And then return true or false based on that. And ta-da, I have the data set that I need. So that's cool. And that's pretty much what filter does. So there isn't much else to say about that. It's like basically you pass out a function. If the function returns true, the end result is an array of all the items in which the function returned true. Again, it's applying this item to each item in the array. So that one's useful and straightforward. Okay. Then there's sum and every. These are pretty cool. They just return true or false, so they don't return you an array. So unlike filter and map, which return you either like the modified array of all the items or an array of a filtered set of items, this returns you true or false, depending on whether something is true for every item or true for some items. So in this case, like let's say I want to check, hey, like is every item even? Is every item odd? I would do this, like const result1 equals my array dot sum. Are some items even? So again, same function again, index, item, index, curly brackets, so you're starting to see the routine here. Okay, and then I just return, and again, it's going to basically what it really means, does the function return true some of the time? So I'm going to just make a function. It'll return true when the thing that I'm checking for is true. How you figure that out is based on what you're trying to figure out, so that's up to your logic. But let's say I'm checking, hey, is the item even? I would just do again item modulo 2 equals 0, and I'm basically asking, hey, are some of the numbers even? Okay, now I could take the same logic, I don't have to change anything, make a result 2 and just change this to every, and that's going to check, is every number even? Meaning, does this function return true every time? Okay. And this is really useful when you're trying to figure out, hey, does everything in this array match this condition? Or do some of the things in this array? So for example, like if I had a list of people who attended at a bar, I might want to check, hey, are some of them under 21? Because even one under 21 is a problem. While, or I might want to make sure that everyone is 21. So it was everyone who was in the bar last night was over 21. Or if you're talking about like a group of people going to a rated R movie, I want to say, hey, are some of the people over 18? Like, as long as one of them is over 18, they're good to go. They can go into the movie. It's things like that. So you can kind of think situations where you want to check whether something is true for everything or some of the things. Okay, so console.log result2. Let's run that. And we can see that, yes, some of the items are even, but not all of the items are even. Okay, so that's pretty cool. Pretty cool. So that's sum and every. Then there is find and find index. Find will return to you the thing. Basically, it's going to try to run the function. Again, the function will either return true or false. And the minute that the function returns true, whatever item that's at, it stops and will return you that one item. So unlike filter, that will return you all the items that match, find index only returns you the first item that matches. So generally, you usually would do this for something that's like unique to that one item. Like, hey, I'm looking for the item with the ID of this, or with this name, and you want to get that specific item. So you're using some sort of unique identifier. Well, let's say I do want to just get like the number. Let's take a look at my string array. So let's say I want to get the first word that starts with the letter Y. Okay? The first letter that starts with the letter Y. So let's see here. Const result. This is going to be for find equals my array2 dot find. And again, same function, item index. This generally will not change for the exception of sort and reduce. And again, a function. And I'm saying, hey, I want to get return whether the item dot split. So we split that into an array. Then I want to check, hey, is the first item in that array, does it equal Y? Okay, and basically what this will do is look for that first item. But what if I'm not looking for the item itself, but where is it in the array? Because I need to do like a splice or something. So I need to know what index is it to do the splice. I can then use find index, which then returns me not the item itself, but the index. So we'll say result 2, and we'll change this to find index. Otherwise, like the way I'd write it out is the same. It's just the return value is different. So console.log result and result 2. Let's run that. So you see, the first time it returned me the item, which is U. So again, that was because again, that's the item that I'm looking for. The one that starts with Y. And see, that's the second item in the array, which would be the index of 1. So see, find gave us back the thing. Find index gave us back the index. So that's pretty cool. But you notice, like this signature is generally always the same. Item index, you do a function. Most of these are looking for you to return true or false. So you just figure out how to return true for the things you want and false for the things you don't want. So that's just a matter of just thinking of your logic for that context. So we're kind of gone through most of them. So I think now we only have the outliers left. So that's going to be reduce. So what reduce does is it does a cumulative operation. So the idea is that you're trying to run like a running total. Okay. So for example, const result 1 equals my array dot reduce. So in this case, the function that it takes is a little bit different. It's always the accumulator, which is the running total, and then the item and the index. Okay, that's the way this works. That's the first argument, and then there's a second argument of where do you want the accumulator to start. Okay, so generally, if I'm going to do a running total of all the numbers in the array, I probably want that count to start at 0. Okay, so now in this function, I would say what I want to do, and what happens is that on each loop, the accumulator becomes the return value of the previous loop. So I'm going to say return the accumulator plus item. So just kind of see how like that would work. So again, let's just say the accumulator, the item, the return value. So on the first loop, okay, the accumulator should be 0, and the item is going to be 1. So 0 plus 1 is going to be 1. So 1 becomes the accumulator when it loops over the next item. So then the next item, its accumulator is 1, the item is 2, so 1 plus 2 equals 3. So then that becomes the accumulator on the next loop. So on the next loop, the accumulator is now 3, but the item we're looping over is 3, so now we're at 6. And this just keeps going till it adds up all the items. And what reduce returns is the accumulator at the end. So you're only getting one value. You're reducing all the items into an array into one thing. That's why it's called reduce, because you're reducing it to one thing. So now if I console log result, I should get whatever that's going to equal. Result, so whatever those numbers added together are, which is going to be 21. Okay, so that's what reduce, but let's say I can also use it to like combine strings. So let's do that with like const results2 equals my array 2 dot reduce. And you can use this for all sorts of contexts. It's not always, now oftentimes we don't want to write accumulator in full. That's like a lot to type. So we'll type item index. So again, slightly different signature. But now since I'm adding strings, really the starting place is an empty string. So that's how I want to start. And then again, I'm doing the same thing. Return ACK plus item. So in this case, if I were to kind of copy this chart over, in the first loop, the accumulator is an empty string, but the first item in array 2 is me. So when you add those together, the end result is me. So then on the next loop, the accumulator is me, and the next item is you. So when you add them together, we should get mu. And then on the next loop, the accumulator is miu, plus, and then the next item is I. So then we should get miu I. Okay, so I've added those strings together. Oops, I didn't console log the result. Okay, so you get me UI. So that's how that works. Okay. Then there is sort. Sorts the array. That's literally what it does. This one actually does alter the array, so keep that in mind. This one's the only one of these that actually does alter the array. You can use sort without a function. Like if I use sort, so if I say like console.log myArray.sort, it'll sort single numbers just fine. And it'll sort an array of strings generally pretty fine. So like generally if you're just looking to do a straightforward sort, this is going to work fairly okay. And that should be a myArray2.sort. So you see like 1, 2, 3, 4, 5, 6, I, me, you. So that's in alphabetical order. And actually let me jumble up that original array. So if I were to put like 6 here and 2 there, it should still give me the same thing. So it's going to sort it just fine. Where we start seeing problems with sort is when you start doing like arrays with doubles. Okay, so if I were to say sort this array out, 1, 2, 55, 66, 4, 8, 9. Watch what happens. Okay, that's not quite numerical order because it's kind of doing it based on the first character. So yes, if I were to just ignore the second character in some of these numbers, that still doesn't quite look right. So we'll see, it doesn't quite sort it well. Okay, and wait a second, I didn't even sort it. I just console logged it. One moment. Dot sort. There we go. Okay, so you see like 1, 2, 4, 55, 6, 8, 9. So it's in numerical order by the first character, but not the way we would consider it. So this is when you need to introduce a callback. And the callback really usually is the item 1, item 2, and then what you do is you have to do some sort of comparison that's going to return either a negative number, a positive number. Okay, so I always just think of it as like -1, and basically item 1, on the first item, what it is, item 1 would be 1, and item 2 would be 2. Then on the next sort, it would be 2 and 55. So what it does, it keeps comparing 2 items in the array. Now, if I just want to do like a straight up numerical sort, I'm going to do return item 1 minus item 2 minus. Now let's think about why. Because let's see here, if item 1 minus item 2, that's going to equal a negative number. So a negative number means they're in the right order. Like a negative number means like, yes, 2 is bigger than 1, so don't swap them. But then if I do 2 minus 55, let me think about that. No, 1 minus 2 equals a negative number. Yep, that's fine. Yeah, and 2, yeah, 55 is still bigger than 2. 55 is still bigger, 66 is still bigger than 55, so far so good. But when I get to 66, because it's going to do just a basic bubble sort, which is not the most efficient sort, it'll do 66 minus 4, which ends up at 62. A positive number means, okay, these are not the right order, so it's going to swap them. Okay, so then 66 and 4 will be swapped. And this is going to keep running through the array and keep doing this until there's no swaps. Okay, so that will work. So if you want to sort something by some other mechanism, then like if I want to sort them by evens and odds, you would just have to like find a way to return a negative number when you don't want them to be swapped, and a way to return a positive number when you do want them to be swapped. So for example, if I want to sort them by odds and evens, I could just say return, and sort is probably the hardest one to kind of think of ways to achieve what you're trying to do. But essentially what I would do is I would just say, first I would check, is the number even? So I would just say, okay, item 1, because all I really care about is whether item 1, well, let me think about that. Actually, yeah, I probably want to do this in a little bit more complicated way, so I'll give some more lines. And what I would do is first I'd figure out if item 1 is even 1. So I would just say, hey, item 1 modulo 2 equals 0. Is that true? Then I would do the same thing for item number 2. Item 2 modulo 2 equals 0. So now I know if they're both even or not. If they're both even, I don't need to swap them because they're both even numbers. I really just kind of want to move the odd numbers to the back. So then what I'm going to return is I'm going to say is even 1 and even 2, are they both true? If they are both true, setting this up as a ternary operator, then I don't want them to be swapped, so I'll return a -1, because again, negative number means no swap. And if they are not, then I'll return 1, which is a positive number, which will swap them. So theoretically, that should sort and put all the even numbers, or the other way around. Let me think about that. Does that work? 1, 2, 55. Let's take a look. 1, 2, 55, 6. I mean, it did do some swapping. 8, 4, 66, 9. Now, why did 9 end up? Because that's not an even number. Okay, and so you see, sorting can be tricky. Because sometimes, like, if they're both even numbers, but that should have sorted. Maybe I put this backwards. Let's try this way. 1, -1. Okay, and that's sorted a little bit differently. Well, sorted in reverse order, so that would make sense. But let me just think about that. Okay, so item true. So if they're both true, then they're both even. Then they should not be swapped. And if they are both, one of them is odd. Okay. Oh, but the thing is that if both of them are odd, it'll still swap them. So that's probably where it is the issue. Or let me think about that. So we might want to be a little bit more complicated about this. So bottom line is the only time I really want to swap it is if even and this is not even. So basically, if that's the case, then I want to swap them. Otherwise, I don't want to swap them. So only when the first number is even and the second number is odd. That's probably the right way to do it. Okay, and let's see if that gave me a better result. 9, 5, 1, 8, 4, 66, 2. Good. Okay, so that worked. See, now all the even numbers are grouped and the odd numbers are grouped. And again, it takes practice to kind of set these sorts up. But the idea is, again, you're creating a function that's going to somehow compare the two items and come back with a logic like swap or not swap. And that's essentially, you can create any kind of sort possible. Oftentimes, if you're using a database and whatnot, it's probably easier to use your database to kind of handle the sorting logic there instead of thinking through it here. But you can. So that's a thing you can do in JavaScript. Although, again, usually if I need to sort something, it's probably a data set I pulled from somewhere that has some other easier sorting mechanism. But this can be very powerful for very, very specific types of sorts that might not be easily expressed elsewhere. So yeah, those are the array callback methods. Hopefully this gave you a good overview of them and how to use them. They are super powerful. I would say I probably use this almost as a lot of the time, because again, oftentimes if you're working in JavaScript, or in programming in general, you're working with data sets and manipulating and transforming and evaluating data sets, which are often given to you in arrays. So array methods are always going to be sort of a heavily used thing in any language. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.